Shalom, Assalamualaikum, Om Swastiastu. Hello everyone, welcome to Physics Laboratory, School of Electrical Engineering, Telkom University. Today, we're going to learn Modul, Measurement of Electrical Quantities. Before we start, we need to know what we should learn first. So, there is going to be 5 parts. First is objective, second is theory, third is tools and equipment, four is practicum and procedures, and last is data processing. For the first part, we are going to know about the learning objectives of this module. For the first part, we are going to know about the learning objectives of this module. Measurement of electrical quantities. There are 3 submodules in this part. Measuring electrical quantities 1. Measuring the internal resistance of a basic matter. For the learning objectives, first, to understand the function and application of a multimeter to measure the internal resistance of a basic matter. Measuring electrical quantities 2. Increasing the range of an ammeter. Able to set up the electrical circuit and increase the range of an ammeter. Measuring electrical quantities 3. Increasing the range of a voltmeter. For the learning objective, able to set up the electrical circuit and increase the range of a voltmeter. After we know about the objectives, we go to the next part, is theory. In this part, we are going to know about the theory that we use in this module. First, multimeter. What is multimeter? A multimeter is an electrical quantities measuring instrument that can also be functioned to measure the voltage, voltmeter, current, ammeter, and resistance, ohmmeter, of an electrical component. There are 2 types of multimeter, digital multimeter and analog multimeter. In this picture, as we can see, there are ampermeter, voltmeter, ohmmeter, port or socket. For the port, as we can see there are 3 holes, left, middle, right. The right hole, we use it for negative load. The middle and left hole, we use it for positive load. Next, Ohm law. The electric current flowing into a conductor is equal to the voltage divided by the conductor resistance. Current equals voltage divided by resistance. The other formula, voltage equals current multiplied by resistance. Resistance equals voltage divided by current. Maybe it's really hard for us to remember that. We just need to know about this thing. That the magnitude of a current that through the conductor between 2 points is directly proportional to the potential difference or voltage across the 2 points and inversely proportional with resistance in between them. So we need to remember, if the current increase, the voltage increase. If the current increase, the resistance decrease. Next, Kirchhoff law. Kirchhoff's first law is total current entering a junction is equal to total current leaving it. So current is conserved, current in equals current out. Kirchhoff's second law is the sum of the currents in all branches meeting at any point is zero because of charge conservation. In this module, we will learn about 2 circuits, series and parallel circuits. A circuit composed solely of components connected in series is known as a series circuit, as we know. Likewise, one connected completely in parallel is known as a parallel circuit. What is the difference between circuit and parallel? The difference between them is components connected in parallel are connected along multiple paths so that the current can spill out. The same voltage is applied to each of them. But in series circuit, components connected in series are connected along multiple paths so the voltage can spill up. The same current is applied to each component. So you just need to remember that. Okay? Next, we need to know about the tools and equipment that we use. Measuring electrical quantities 1. Measuring the internal resistance of a basic matter. Tools and equipment. First, multimeter. Second, 10 kilo ohm or 47 kilo ohm resistor. Third is grid socket, the gray one. For jumper, the red and black cable. Power supply, and basic matter. Measuring electrical quantities 2. Increasing the range of an ammeter. Second, same as the first module. But in this part, there are an additional tool, namely shunt resistor or shunt obstacle shunt, which is arranged in parallel to the basic matter, so we can increase the measurement limitation of ammeter. Measuring electrical quantities 3. Increasing the range of a voltmeter. Same as the first submodule, but in this part there are an additional tool, namely multiplier resistor or R multiplier, which is arranged in series with the voltmeter, so we can increase the measurement limitation of voltmeter.
Welcome to the online practicum. This time we will do a practicum measuring electrical quantities. This module will be divided into 3 sections. The first is to calculate the internal resistance of the basic matter. The second is how to increase the measurement limit of the ammeter. Third, to increase the measurement limit of voltmeter. Before starting the practicum, I will introduce the tools that will be used. First, the direct current power supply, then there is the galvanometer, shunt resistor, multiplier resistor, 47 kilo ohm resistor, multimeter, socket grid, and lastly a jumper wire for connecting. For the first submodule, we will measure the inner resistance of a basic matter. Basic matter and galvanometer generally have the same working principle, but the galvanometer can measure the current direction. So, in this practicum, we will use the galvanometer. The first thing to do is to connect the power supply to a resistor using a jumper. The reason for connecting to the resistor so that the current flows according to the Ohm's law. I equals to V divided by R. Then, from the resistor, connect to the galvanometer. After the galvanometer returns to the power supply. To measure the internal resistance, we will use a multimeter parallel to the galvanometer. Connect from the positive pole of the galvanometer to the positive pole of the multimeter. And remember, on a multimeter, the negative pole is marked with the symbol grounding, or here is written common. After that, we will turn on the power supply and use a multimeter which is set in voltmeter mode. In this experiment, we will calculate how much voltage is on the galvanometer when the current is flowing, which at this time is 20 microamperes. In experiments with a current flowing of 20 microamperes, the voltage that appears on the galvanometer is 22 millivolts. When the current flowing in the galvanometer is 30 microamperes, the voltage that appears on the galvanometer is 33 millivolts. When the current flowing in the galvanometer is 40 microamperes, the voltage that appears on the galvanometer is 45.5 millivolts. Well, from the first submodule, try to explain the role of the multimeter in calculating internal resistance. Besides, how to calculate the inner resistance. Have a great time doing it. For the second submodule, we will still use the same tools, but this time with the help of a shunt resistor. For the first practicum steps is to connect the power supply with a jumper to the resistor, then connected in series with a multimeter. After from the multimeter, we proceed to the galvanometer and then return to the negative pole of the power supply. The difference in the submodule this time, we will use the help of a shunt resistor, where the shunt resistor is a resistor parallel to the galvanometer. To parallel it, we only need to install the shunt resistor anywhere on the socket grid and then parallel it with the galvanometer. For experiments to increase the limit of measuring ammeter, we need to set the multimeter to ammeter mode for direct current, because we are using a direct current power supply. Because we use a weak current, we use the smallest measurement limit of 2 mA on the multimeter. We turn on the power supply, then we will calculate how much current flows in the entire circuit and how much current flows only on the galvanometer. For this experiment, when the galvanometer shows the number 10 microamperes, the multimeter shows that the current flowing is 0.1 milliamperes. When the galvanometer shows the number of 20 microamperes, the multimeter shows that the current flowing is 0.2 milliamperes. When the galvanometer shows the number of 30 microamperes, the multimeter shows that the current flowing is 0.31 milliamperes. For the next, we will compare the shunt resistor that was previously valued at 50 milliamperes with the 100 milliampere one. Then we will see the difference. When the galvanometer shows the number 10 microamperes, the multimeter shows the current flowing is 0.01 milliamperes. When the galvanometer shows the number 20 microamperes, The multimeter shows the current flowing is 0.02 milliamperes. When the galvanometer shows the number 30 microamperes, the multimeter shows the current flowing is 0.032 milliamperes. That's it for the second submodule practicum. So, from the second submodule practicum, try to determine the role of the shunt resistor in this submodule. Then, how can the shunt resistor cut the current with the resistance it has? Good luck while working on it. For the third submodule, we still use the same tools, but we use the help of the multiplier resistor. The first step is to connect the power supply to the resistor. After that, the resistor will be connected in series with a multiplier resistor. After being connected in series with the multiplier resistor is also connected in series with the galvanometer. Then, from the galvanometer, back to the power supply. In this experiment, the multimeter will calculate the voltage through the multiplier resistor and galvanometer. Therefore, we will parallel the multimeter from before the multiplier resistor to after the galvanometer. This time, the multimeter will measure the voltage. Therefore, we will set it to direct current voltmeter mode because it uses a direct current power supply. And now we're going to take measurements. When the galvanometer shows the number 10 microamperes, the voltage shown on the multimeter is 100 millivolts. When the galvanometer shows the number 20 microamperes, the voltage shown on the multimeter is 180 millivolts. When the galvanometer shows the number 30 microamperes, the voltage shown on the multimeter is 360 millivolts. We will do a comparison with the other multiplier resistor. The first multiplier resistor used was 1 volt, and now we will use the 10 volt. When the galvanometer shows the number 10 microamperes, the voltage shown on the multimeter is 25 millivolts. When the galvanometer shows the number 20 microamperes, the voltage shown on the multimeter is 35 millivolts. When the galvanometer shows the number 30 microamperes, the voltage shown on the multimeter is 70 millivolts. That is the case for the third submodule practicum. Well, after doing the third submodule practicum, try to determine the role of the multiplier resistor in the submodule. And you can also determine how the multiplier resistor can divide the voltage. Have a great time doing it! That's the practicum for the module of measuring electrical quantities. Hopefully you can understand it.